In this video, we're going to examine different tables and determine what types of functions these tables have when we're given the domain and the range. Notice in all three tables, I'm actually giving you the same exact domain of -2, -1, 0, 1, and 2. But notice that the range is different in each. So we're going to looking at that range and determining how our consecutive terms are bonded and then determining what type of function we're looking at. Also remember that we know that linear functions are functions with a constant rate of change, and from one term to the next, consecutive terms are bonded with addition or subtraction. Exponential functions are functions where consecutive terms are bonded with multiplication or division, and the quadratic functions are the new types of functions, and I'm going to show you how to determine that a given function table is quadratic and then how to write the equations of all of those types. So let's look first at our first table on the left-hand side over here, and I'm looking at my y values or my outputs for these consecutive terms, and I'm checking to see if I notice any patterns. And I notice from 5 to 8 I added 3, and then from 8 to 11 I added 3, and I'm noticing that pattern remains constant. And that tells me that I'm talking about a linear function, and I know that when I'm looking at a linear function, I can take any term and subtract the previous term to get my common difference. So 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3, and 17 minus 14 is 3. So my constant rate of change is positive 3. I also know that using the equation given for linears, which is slope-intercept form, y equals mx plus b, I know that my b value represents my y-intercept, or where this line crosses the y-axis, and I know that that's where x is 0. So I'm looking right here, and I see that my y-intercept is 11. And we already determined that our constant rate of change is 3, and the constant rate of change is my slope. So my equation for this line is y equals 3x plus 11. If I wanted to graph that on a coordinate plane, I would begin where y is 11, and then my slope is a rise of 3, run of 1. So my line would look, something like this. Now let's look at our second table. And in this table, I notice from 1 to 4, I could think about I added 3, but if I look from 4 to 16, I notice that that pattern does not repeat. So now I'm thinking about multiplication and division. And I notice from my first term to my second term, I multiplied by 4, and that pattern repeats. 4 times 16 is 4, 16 times 4 is 64. So that tells me I'm talking about an exponential function, and I know I can use my common ratio. Common ratio is when I take any term and divide by the previous term. 4 divided by 1 is 4, 16 divided by 4 is 4, 64 divided by 4 is 4, and 256 divided by 4 is 4. I also know that my equation for exponential functions is y equals a times b to the power of x. B represents my multiply by 4, and a represents my initial value, or my y-intercept. And I know that y-intercept is where x is 0. So my function is y equals 16 times 4 to the power of x. And if I wanted to graph that on a coordinate plane, I have a point 0, 16, and then, oops, Again, I moved that. And then talking about exponential growth. So it looks something like that. Now let's look at our third table. Our third table, I have that same domain again, and I'm looking from 6 to -10, and I notice that from 6 to -10, I subtracted 16, which does not repeat for my next two consecutive terms. And so now I'm looking for multiplication and division. That doesn't work either, so now that's a hint to me that I'm going to need to look at my second difference. So I'm first going to calculate what my first difference is between consecutive terms. The difference between 6 and -10 is 16. The difference between -10 and -16 is 6. The difference between -16 and -12 is 4. And the difference between -12 and 2 is 14. Now I'm going to look at what's called that second difference. And I just noticed that this should be -16 and -6, and that's because if I take -10 and subtract 6, I get -16. And if I take -16 and I subtract -10, I get -6. And that's important with my second difference here. Now I'm looking at what's called the second difference. If I take -6 and I subtract -16, I have +10. If I take 4 and I subtract -6, +10. And if I take 14 and subtract 4, +10. This blue part is called my first difference, and this orange part is called my second difference. Notice that second difference is constant. That tells me that I'm talking about a quadratic function. And I know that the formula for a quadratic is y equals ax squared plus bx plus c. Now, the first thing I know is that my c value is my y-intercept, which is where x is 0, so that means my c value is -16. There's also a quick and easy way to figure out what my a value is, and that is just to simply take that second difference and divide that second difference by 2. So that means that my a value is 5. So far I have y equals 5x squared plus bx minus 16. And since I have a table of values, I can use any ordered pair, an x and a y value, to figure out what that unknown value is, which the unknown value here is b. So I think I'll just use an easy when x is 1 right here and y is -12. So that means every time I see x, I'm substituting in 1, and every time I see y, I'm substituting in -12. So -12 equals 5 times x is 1 plus b times 1 minus 16. And let me solve this equation. So I have -12 equals 1 squared is 1 times 5 is 5 plus 6 times 1, 1 times b is b minus 16. And I'm simply going to just make some workspace over here, and I'm simply going to solve for b. So I have -12 equals, when I combine 5 and -16, -11 plus b. I'll add 11 to both sides. So b is equal to -1. So that means I can go back to my original equation where I had solved for some parts, and I'm going to replace this b value here with -1. So I'm going to replace that right here with -1. So here is my equation for this function. And I know a couple of things about this. I know I could plot all of these points, and I know that I have a parabola. I also know, because my a value is positive, that it's going to be an upward facing parabola. And I also know that my y-intercept is at -16, so I certainly could sketch that. Hope this is helpful.